changing my tie to alkali metal tie.
You have an alkali metal tie?
It's a new tie I've just got. This one's a Dutch one. I was given it on Saturday. He gave me this one. So here you can see we have the alkali metals.
Oh, hang on, where are they? Yep.
Here. And the alkali metals are very reactive. So we've seen that lithium doesn't react very much. But then as you go to sodium, and then to potassium and rubidium, the violence of the reaction gets more and more and more. And cesium is even greater. I don't know whether the people making this tie were so frightened that they didn't put it on, but in each of these cases the reaction is removing one electron after another, one electron from the outer atom, outer shell of the atom, and the bigger the atom, the easier it is to remove the electron. And as you go down the periodic table, the size of the atom increases, so it's easier to remove the electron. So francium would almost certainly be even bigger than cesium because it's a whole row lower down, and so that should react with water with enormous violence. But unfortunately, francium is very radioactive, and you can't get a nice lump of francium the sort of size that you'd like to throw in water to make the YouTube video of the century. Francium, which is named after France, was discovered by one of Madame Curie's pupils in 1939, 5 years after Madame Curie herself died. I always thought that it was Madame Curie that discovered it, but in fact it was discovered after her death. But its properties would probably be similar to those of cesium if it was not very radioactive. But radioactivity like that makes it very difficult for chemists to study the chemistry in enormous detail. Chemical reactions are really quite sensitive to temperature, and radioactive materials, as they decay, give out energy, so the compounds themselves tend to heat up. A lump of plutonium, which is very radioactive, is really quite warm to touch, and francium, which I think is more radioactive, is probably very warm. So I think the melting point of francium will be lower than that of cesium because the melting points go down the group, and because it will be generating heat, almost certainly francium would be a liquid at room temperature. But I've never seen it. It might well be coloured as well because cesium is golden coloured, so I would not be surprised if francium was red, but I have no idea, and I'm not sure if anybody knows.